Alright, and welcome to Unit 10 Review, All Things Rational. Now, number 1 says find the domain of the rational function below. The way I taught this in class, I had you graph it. However, I'm going to show you a very, very highly simplified way to find the domain without having to worry about the graph at all. So really easy. Alright, so what's step 1? Okay, step 1 is we simply want to factor. We want to factor. So we could write this as f of x. I'll look at the numerator and I ask myself, hey, can I divide all of these by the leading coefficient of 3? And of course the answer is yes. So I factor out the 3. 3 divided by 3 is 1x squared. Negative 9 divided by 3 is negative 3x. And negative 30 divided by 3 is negative 10. All of this is of course still over x squared plus 9x plus 14. Okay, now we have f of x is equal to, and now I can do the actual factoring. So here I'll put the 3, and let's use a different color. Let's say on the top, this right here will factor into x, let's see, plus or minus something. What are two things that multiply to be negative 10, but then add up to be negative 3? Well, let's see here. Negative 10 is some combination of 5 and 2, and can some combination of 5 and 2 combine to be a negative 3? Well, let's see here. If we did negative 5 plus 2, well, that would be negative 3. Negative 5, and then x plus 2. Okay, let's use a different color here, and let's factor the denominator, x squared plus 9x plus 14. Let's see, that would split up into x plus or minus something and x plus or minus something. And think about this. What two things does 14 split up into? Now let's just try 7 and 2. Well, 7 plus 2 is 9, so yeah, those are the numbers. So x plus 7 and x plus 2. Alright, I'm going to make this as simple for you as possible. The factor in the denominator that does not cancel, that is our vertical asymptote. And the factor that does cancel, that is where our hole is. Now, if we were to set each one of these equal to 0, well, x plus 7 equals 0, you would find that x is negative 7. And if we were to set x plus 2 equal to 0, you would find x is equal to negative 2. Here is what you do for your domain. I cannot make this any easier, okay? So you always say, hey, our graph starts going to the left forever to negative infinity, comma, and you look for the smaller of these two numbers, and negative 7 is smaller. So I say negative infinity union, and then whatever you break on the left at, you restart on the right, negative 7 to the next number, negative 2, union, negative 2, comma, and then back to positive infinity. Now let me go ahead and erase the board, and let me just write this out just a little bit nicer and neater. But yeah, it is that simple. Alright, so I'll just kind of write the domain one more time. We go from negative infinity to the smaller of the two numbers, negative 7, union, negative 7 to negative 2, the larger of the two numbers, union, negative 2 to positive infinity. And it is that easy to find the domain. Alright, pause the video, finish taking notes, and let's move on to our second example. Okay, this says simplify the rational expression shown below. Well, what you always want to do is you simply want to factor everything in the denominator. Now, sometimes this is easier than not. Right here, x squared minus 6x plus 8. With a little bit of thought, you could find that that's actually x minus 6 and x minus 4, because a negative times negative is a positive 8. And negative 2 plus negative 4 is negative 6. Now, this is where it gets a little bit trickier. How in the world can you factor 3x squared minus 5x minus 2? Well, this would be our third time using factoring by grouping in this worksheet. So we do our a times our c. 3 times negative 2 is negative 6. And two numbers that multiply to be negative 6 but combine to be negative 5 would of course be negative 6 and positive 1. So I can do it like this. 3x squared minus 2. Let's put our minus 6x and our plus 1x right here. Okay? So I put these two things into our groups, and from here we say, well, you know, what is the greatest common factor? What's the largest thing that I can pull from both of these? And hopefully you're thinking, well, 3 and 6, I can definitely pull it a 3. And there's two x's and there's one x, so we can definitely pull out an x. Cool. Over here we have a 1x minus 2. The largest thing you can pull out is a positive 1. And what in the world are my leftovers? Well, 3x squared divided by 3x is just x. And negative 6x divided by 3x is negative 2. And of course here when you pull out a 1, you don't really change anything. There you go. And you could ask yourself, well, hey, wait a second. Have I factored this correctly? And the answer is yeah. If these two things are the same, I can factor out that x minus 2, pull it out from both of them. And then my leftovers are going to be whatever's left over. So 3x plus 1. Hey, that was pretty redundant, right? Now at this point, I can actually kind of rewrite my initial problem. So here's what I encourage you to do. Pause the video, finish taking your notes, and let me kind of clean this up for everyone. Okay, now you're going to notice that I did one thing here. So after factoring this and factoring that, both denominators, and getting this and getting that, the other thing I did was I took my negative right here, I made it a positive, and I distributed that negative to both terms. So my positive 6x became a negative 6x, and my negative 7 became a positive 7, which you can see those two signs right there. Okay, so what in the world do we do in order to add these two fractions? Well, they need a common denominator. In fact, I'd like for you to write that. Need a common denominator. All right. And what I notice is that x minus 2 and x minus 2, those are the same thing. So I see, hey, this x minus 4 is over here on the left, but it's not on the right, so let's write x minus 4. Now if I multiply the bottom by x minus 4, I have to multiply the top by x minus 4. And let's see, we have one other thing over here. Let's see, I'll use a different color. Let's use this kind of blue right here. I have this 3x plus 1 right here. So I need to multiply this side by 3x plus 1. Okay? Now, from here, I really don't want to leave y'all too much in the dark, so here's what I'll do. I'm going to do one more little step, and then I'm going to leave it up to you to finish the problem from there. Notice that on both of these numerators, you have two terms times two terms. How in the world do we do 2 terms times 2 terms? Well, we'll create a box, and we'll put 3x plus 1, so this is our first factor here, and we'll put our second factor, this x squared, plus 5. And let's multiply these things. X squared times 3x is 3x cubed. X squared times 1 is x squared. 5 times 3x is 15x. And 5 times 1 is 5. That means that in my first fraction, before I can multiply anything, I have 3x plus 1, x minus 2, x minus 4, and in the numerator, I have this 3x cubed plus x squared plus 15x plus 5. So pause the video, finish taking these notes, but like, what are we ultimately trying to do here? Well, we're trying to add these two fractions. So what I've done is I've simplified one of the fractions for you. So what you have to do is over here where you have x minus 2, 3x plus 1, and x minus 4. It is up to you to figure out what goes here by using the box method. And then from there you want to simply combine all your like terms. I'll put this as a final note to finish the problem. Combine all like terms. Okie doke. Alright, I hope this is helpful. Let's move on to our third and final example. Okay, number 3. Solve the equation below for every solution. This is, in my opinion, the hardest problem that we see in second semester Algebra 2. And as such, I'm going to walk you through the whole problem. What I would encourage you to do at this point, if you've been watching all these videos, you've really been taking your time on this, I'd encourage you to take a quick break, come back to this in 5 to 10 minutes. Give your brain a little time to relax, okay? And whenever you're ready, come on back and let's start this problem together. Okay, so here's what we want to say. Whenever we are solving some sort of rational equation, we need everything in the denominators to be the same. Notice x squared minus 25, can actually be factored as a difference of squares. It can be written as x plus 5 and x minus 5. Okay, so if I write this as x plus 5 and x minus 5, I can actually kind of rewrite my whole equation. I could write it as 2x squared over x minus 5. And then, you know what, I'm always going to do this with my negative. Anytime I see a negative, I'm going to switch it to a positive and distribute it to both of these. So here I'm going to put plus, and on the top I have a negative times a positive, which is a negative 2x squared, and a negative times a positive, which is a minus 7x. And of course, this is all going to be over what we factored, that x plus 5 times x minus 5, and it's equal to 3x over x plus 5 and x minus 5. Now from here, notice there's an x minus 5, x minus 5, x minus 5. So here we are missing this x plus 5. Okay, so I'm going to multiply the top and bottom by x plus 5. And from here, I can distribute this 2x squared. 2x squared times x is 2x cubed, and 2x squared times 5 is 10x squared. Now notice, because all of these denominators are the exact same, we can actually just ignore them, and we can write the rest of this. I can bring down, here I'll use different colors to show you, I can bring down this minus 2x squared minus 7x, and I can then set that equal to that numerator, 3x. And at this point, because we see some squares and we see some cubes, we know we want to set this thing equal to 0. We can do that by simply subtracting minus 3x and minus 3x. And at this point, this is what we have. We have 2x cubed, and then I have bad handwriting, but that's actually a 10, not a 6. So I have 10x squared minus 2x squared, which is plus 8x squared. And I have a negative 7x minus 3x, which is minus 10x. And this is, of course, equal to 0. Now what I have to do is I have to solve this by factoring it. So I want you to pause the video, finish taking notes as necessary, and then let's go ahead and tackle this together. Okay, so the first thing I notice is I always want to ask myself, can I factor out the greatest common factor? 2, 8, and negative 10 can all be divided by 2, and x cubed, x squared, and x can all be divided by x. So I can, right off the bat, I can make this a whole lot easier by factoring out 2x. This is going to leave me an x squared, and 8x squared divided by 2x is plus 4x, and negative 10x divided by 2x is negative 5x. Okay? So I always want to keep this 2x on the outside, and then from there, I can actually begin to split this up, and, oh, I'm so sorry, there's no x there. Negative 10x divided by 2x is just negative 5. Okay, and so I can split this up into x and x, and I'm looking for two things that multiply to be negative 5 but add up to be positive 4. And that could be a positive 5 and a negative 1. So x plus 5 and x minus 1. Now here's what we want to do from here. We want to say, okay, in order to solve this, these are all, the whole function set equal to 0. I want to set each of these equal to 0. So let's see, we can do 2x equals 0. Here I'll use different colors here so you can see the difference. I'll do x plus 5 equals 0. And I'll do x minus 1 equals 0. At this point, I can kind of erase this problem down here. And when we solve this, well, solving for x here, I divide both sides by 2, and x is equal to 0. Here I subtract both sides by 5, and x is equal to negative 5. And here I add 1 and add 1, and x is equal to positive 1. Now these are all of my possible solutions. And the way that I test these possible solutions are, I test them against my denominator. Remember, x squared minus 25 is in the denominator, and that's split up to x minus 5 and x plus 5. And so you want to say, essentially, like, where can x not equal 0? So we find this by setting our denominator, x minus 5 equal to 0, x plus 5 equal to 0, and notice x cannot equal, in this case, positive 5, and in this case, x cannot equal negative 5. And then what you do is you compare your two sets of numbers, and you look for a number that's the same. Notice here we're saying x could equal negative 5, but here we're saying x cannot equal negative 5. And because it's over here on this list of things that x cannot be, we can cross it out and we get our actual true solutions are x equals 0, comma, and 1. Okie doke. And this would be our final answer. Alright. Y'all, I hope this review is helpful. Good luck on your test on Thursday and Friday, and I'll catch you guys next week.